Do I have to train the quality engineer to go into that engineering model that we've never, ever touched before and balloon there? Well, oh my gosh, I just broke the entire construct of the org chart. And all the roles and responsibilities have to get shifted and shuffled. And I think that's a really hard thing for organizations to tackle, is that role change.
Growing a business requires a holistic approach that extends beyond sales and marketing. This approach needs alignment among people, processes, and technologies. So if you're a business owner, operations, or finance leader looking to learn growth strategies from your peers and competitors, you're tuned into the right podcast. Welcome to the WBS Podcast, where scalable growth using business systems is our number one priority. Now, here is your host, Sam Gupta.
Hey everyone, welcome back to another episode of the WBS Podcast. I'm Sam Gupta, your host and principal consultant at digital transformation consulting firm Elevate IQ. Most manufacturers struggle with cross-functional collaboration, especially when it comes to engineering handoff, because it requires going beyond the engineering perspective. Engineers need to think from the perspective of consumers. These consumers could be anywhere from machinists, assembly technicians, welders, inspectors, and purchasing. This thinking requires several changes in the organization, including a deeper understanding of the needs of these consumers, adoption of digital processes, and cultural transformations. In today's episode, we have our guest, Jennifer Herron, who discusses how 3D CAD models can improve cross-functional collaboration and design from consumers' perspectives. She also describes the engineering handoff process and cultural barriers in adopting digital processes. Finally, she describes the stages of design processes and the tools relevant at each stage and which industries are most appropriate for adopting 3D CAD models. Let me introduce Jennifer to you. Jennifer Herron is the CEO of Action Engineering, a company that helps manufacturers build a resilient, future-centered, on-connected, trusted models and an uplifted workforce. She serves on the Digital Metrology Standards Consortium, also known as DMSC, Board of Directors, and is the ASME MBE Vice Chair. She holds a patent for a snake propulsion mechanism and is the author of Reuse Your CAD, the model-based CAD handbook. With that, let's get to the conversation. Hey, Jennifer, welcome to the show.
Oh, gosh, thanks, Sam. I'm excited to be here.
And I am super excited to host you as well. Just to kick things off, do you want to start with your personal story and your current focus?
I can definitely do that. So when I started as a mechanical engineering designer back in the 90s, I used to design spaceships and robots. I started at the detailed part level, like brackets that mounted onto the inside of space capsules. And then I started working on mechanisms that held the space capsule together and opened the space capsule. Yeah. And then I ended up managing large assemblies, large CAD model assemblies in a whole bunch of different CAD systems. Okay. And the last two big assemblies that I worked on were the launch abort system for the Orion manned spacecraft, and that was done in Creo. And then I also worked on the original Dream Chaser spacecraft, and that was done in SolidWorks.
Wow. Okay, that's quite a work because they are extremely complex.
They are
in
complex.
Design and in manufacturing as well. Okay, so we are going to dig into all of that. And since your space is going to be 3D modeling, and when you are designing these complex parts, 2D is not going to be enough. That is for sure. So we are going to dig into all of that, but we have one of the standard questions that we ask all of our guests before we get into today's topic, and that is going to be your perspective on business growth, Jennifer.
Yeah, well, you know, what I learned from the over 15 years of daily CAD design and management, and then having those parts being fabricated, inspected, was that how we use the CAD models today, we could do that more efficiently. And that really launched me into my current obsession of improving how manufacturing companies use and reuse 3D data. So what we've seen in the past, probably about 8 years of growth in the 3D model CAD industry has dramatically evolved. And that's why I released my Reuse Your CAD model-based handbook. First released it in 2013 and just did another release here in this year in February. And what I found from 2013 to 2021 is that the fundamentals didn't change too much about how we do large CAD assembly management.
Yeah.
But we needed to go beyond the designer perspective. And that's the growth that I'm seeing today about kind of this swirl around 3D models, digital twin, digital thread. How do we use all this data in Industry 4.0? Is that we have to be able to look at the 3D models from the perspective of the consumers. And those are people like the machinists, the assembly technicians, the welders, the inspectors, the purchasing people. That is huge. How do we interact with the supply chain with these models? So that's kind of the major growth. We went from we're designers sitting in our cubicles making spaceships to, okay, now we have to understand how the factory floor is actually using the 3D information and what do they need and how do we best make their processes the most efficient for them.
Okay, so let's talk about this perspective of it. And we have had a lot of different guests on this podcast as well who have spoken about the disconnect between your engineering department and also the shop floor. So talk about the differences. Let's say if I have the perspective of an engineer versus the perspective of, let's say, the machinist. In your case, you mentioned that this is going to be a consumer. So how do they see things differently? What are they looking at? Let's say if I have a machinist or engineer, what are the differences in the perspectives?
Yeah, well, you know what? Back when I was a newbie designer working on NASA spacecraft, I'd sit in my cubicle all day long, 8 hours a day, designing on, I think it was unigraphics or ideas. That's what I learned on early. And I'd make all these things and they were on my screen. And I don't know, screens were about 20 inches at the time. And I would take this part and I would make a drawing and I would head to the shop floor and I would hand it to the machinist and they would go,
and I know how that interaction is going to go, right? Here.
Yeah. What have you done? Like, I don't know how big this thing is. You didn't put the right dimensions. What's the tolerance? How important is this hole compared to that hole? And so that learning experience as a young designer, it really holds true today for all engineering to shop floor interactions, right? Is that the designers are very disconnected from how the parts get fabricated. And we've got to break down the silos between how the engineers sitting in their air-conditioned cubicles and the factory floor, which is loud and chaotic, and there often aren't very many computers, so they're not particularly computer-savvy people. So that's the area that we work in and that I help people with, is to say, here's how we can author the information. If you're a designer, if you're Jennifer sitting in your cubicle, author the information this way, and then Bob, who's the inspector, uses the information in the way that he knows how to make sure that you built the parts, that the parts were built according to the engineering specifications.
Interesting. So I am definitely going to dig deeper into that. And from my perspective, if I look at the manufacturing organizations that I have personal experience working with, when it comes to this siloed nature of the engineering versus production, there are a lot of factors involved in that. And, you know, a lot of those are going to be cultural, political, it's going to be compensation, it's going to be org structure. So it's not just that the engineering can simply walk to the production floor and they will tell them everything. There are a lot of different other factors involved. So how 3D models can solve this problem? can 3D models tell or inform the designers that this is how your production processes are set up, and you are visualizing this in the real environment so that they have some sense, even if the manufacturing or the production or purchasing, they are not necessarily telling what is going to be required on the production floor? Can 3D models assist with this?
Yeah. So let me hone in on the concept of politics, and I'll give you an example. So there's definitely politics and posturing and an organization chart that exists today in manufacturing organizations, right? So you have an engineer, you have a manufacturing engineer, and you have a quality engineer. So design, manufacturing, and quality.
Yeah.
And what we have found when we're working with converting drawings in the process is we have a lot of value in the first article inspection process. And so what that typically looks like is design engineer puts the geometric tolerances, GD&T, onto a drawing. And then the quality engineer takes that drawing and with their pencil and oftentimes several colored highlighters, highlights up that drawing and then goes in with the balloon and it bubbles and balloons the drawing. And then they pass it over to the coordinate measurement machine programmer, who then takes that drawing and their highlighter and their red pen and they mark it all up. And then they manually program the coordinate measurement machine. There is a ton of manual handoff in that process. Yeah. So and we know there's like in a worst case scenario, and this is real data that we've worked with a real company, there's like 20 different manual handoffs of that particular information. So there's a lot of room for improvement. But this is where the politics gets in the way. It's obvious if we go to using a 3D model where the balloons are identified in the 3D model along with, in conjunction with, and machine readable to the geometry that they represent in that 3D model, seems totally obvious to everybody. Yeah, this is perfect. This is great. But then everybody says, no, wait a minute. My quality engineer, are they out of a job? That's the first question. Second question is, do I have to train the quality engineer to go into that engineering model that we've never, ever touched before and balloon there? Well, oh my gosh, I just broke the entire construct of the org chart, right? And all the roles and responsibilities have to get shifted and shuffled. And I think that's a really hard thing for organizations to tackle, is that role change. We sort of see that it's obvious that in the 3D model, we can make huge savings. And in the first article inspection from Path, by the way, there's an 80% time savings in there when you use the automation tools that are available, which is great, let's get the 80%. And everybody goes, no, we can't do that because, Bob, the inspector, might lose his job. So we'll just keep letting him balloon the drawing. And that, I don't know, this is a people thing, right? So you have to do a big acknowledgement of the fact that you're going to shift around people's roles and responsibilities, and you're going to have to upskill your people.
Yeah, and obviously we don't want Bob to lose a job, or anybody to lose the job, to be honest. I mean, we don't want anybody to lose a job. We want everybody to be better at whatever they are doing, right?
That's right. Okay. And it's right. We don't want Bob to lose a job. And I always have to be really, really careful about that when we teach people about model-based definition, which is just annotating your CAD models, because they get really, really nervous. And I understand that, right? Because you don't want to lose their job. But so they get nervous on two levels. They might be nervous about losing their job, but then they're also nervous about, you know what? I was going to retire in a couple of years, and I'm not really sure I want to go learn a whole nother way to do my job. And so, it's tricky. And I think the organizations that have success using models throughout the process are very sensitive to and honor those ways, those kind of people. Like if Bob is really good and fast at doing inspection, first article inspection using drawings, great. Leave him doing that, because leveraging model-based data, 3D model-based data, does not mean all your drawings go away. It means you want to go after all of that return on investment for the stuff on models that really does bring you high value. If you've got drawings that are working well, and you've got an inspection loop that's working well, and you've got a fabrication loop that's working well, don't touch it, right? Leave that alone. But if I have a really complex, I work with a lot of gas turbine airfoils. If you have a lot of crazy geometry that is, there's nothing orthogonal about any of it. If you have that kind of geometry that's really complex, go after that first. That's really your low-hanging fruit, because the drawings are flat out totally inadequate to represent that crazy geometry.
Okay, so I am actually going to ask you one question, and that is going to be related to the overall role of PLM system in this process. And I don't know
it's a good question.
If the organizations that you work with, they utilize the PLM as part of their processes or not, but PLM is going to have some sort of quality module built as part of it as well. This quality is not necessarily going to take care of, let's say, your in-process quality or the ERP side of things, but from the PLM perspective, from the design perspective, and from the programming perspective of these machines, you can probably do this in the PLM. The quality engineers can go to the PLM software and they can visualize these processes. So have you had challenges in dealing with the PLM software? Do you utilize PLM software in conjunction with what you are doing, or is that completely separate?
No, it's an excellent question. And I giggle at when you say, you have challenges with the PLM software? Yeah, everybody has challenges with the PLM software. But it's because it's complex, right? As you said at the very beginning, this is really complex data that we are dealing with. So people are really comfortable with the 2D drawing because it's flat, it's static, it doesn't move, it's not dynamic. We're not updating it in real time. We do that with models because we want it to be dynamic and interactive and totally rich with all the data we can possibly get our hands on. And we're updating it real time. And that kind of freaks everybody out. But when we do that, when we move away from this static drawing, just document revision control, we have to be in a sophisticated, at a base level, relational database that's managing the interactions of all the 3D data. So if I have a landing gear system for an airplane, I've got the main strut, I've got the wheel, I've got the lug nuts, I've got the damper itself, I've got a wire harness, I've got connectors, I've got the little NAS 1352 fasteners that hold on the harness, I've got P-clamps, there's all these pieces and parts. And when you're in a 3D system, you have to have a database that is collaborating, connecting, making sure everything is up to date, managing all the users who access the data. If you are a factory floor worker, an assembly technician for that landing gear, you must only see the latest revision, because if you see the old one, you're going to build it the wrong way. But if you're the engineer up in the tower, and you are updating revision B to revision C, well, you're working on revision C, so you got to see that. So that's a lot of what happens with PLM tools, is managing the revisions, the versions, who sees what, when, and where. How does the P-clamp interrelate to the harness? And how does that P-clamp then get connected to the strut of the landing gear? So it's just super complex. And so you got to, the short story is, Sam, you got to have it. PLM, or at a minimum, a PDM, a product data management system, is required for model-based data, because you just won't be able to keep it straight in flat files.
Interesting. So let's touch into some of these stories that you have worked on, and I'm pretty sure you are going to have very exciting stories. So maybe you can talk about some of the resistance that these companies had when you started implementing these 3D models. Obviously, we both know that there are going to be some benefits when you remove that manual intervention, but unless they use it, unless they live through it, it's going to be very hard to communicate the value of it. So do you have any stories that you might be able to share of the organization that was not utilizing 3D models before, but then they started using and they saw a real change?
Yeah. Here's one story that's my favorite. I worked with an organization that built some commercial parts, and they had a lot of covers for things.
Yeah.
And they did a lot of sheet metal forming. And so we took a look at that part very specifically. And I go, okay, so you've got a cover for this light, and it's built out of sheet metal. And I said, can you invite the supplier to our meeting? Let's do a little bit of model-based definition training and talk about how these models can be reused.
Yeah.
And so we took a look at it, and I said, hey, supplier, so here's the drawing that Mark made.
Yeah.
Can you tell me? And I walked over to the supplier and I said, Mark made you this drawing. What do you do with this drawing? And the supplier stood up and walked over to the trash can and threw it in the trash. He said, I don't use your drawing. I don't look at it. You guys send me a SolidWorks model. So I just used that directly in the machine. And everybody in the room went, what? Wait, what? You mean we're up here making these drawings and you throw them away? And so I turned to the engineering manager and I said, so I'm going to suggest you no longer create drawings for this particular supplier because that is a waste of your time. Boom.
Yeah.
Like huge. I mean, it takes like a week to make a drawing of something. Depends on people's skill level and experience and all that kind of stuff. But roughly from start to finish, and by the time you get it all approved, we're talking about a week's time. So could you save a week if you had really good conversations with those people that were building your parts and get down into the nitty-gritty details of what information do you need? And am I giving you the right information? And if I change the information to, in this instance, I'm going to stop giving you a 2D drawing and I'm just going to send you the 3D model. How does that work for you? And in this case, it was like a win-win and everybody went away happy. So that would be my story about like a really obvious, straightforward thing that just came out of a simple conversation around how to use model-based data. We tend to, especially as engineers and analytical type personalities, I myself am included in that, we overanalyze what we think people need instead of just saying, what is it that you need to do your job?
Yeah, completely agree. And I can relate with this story so much because we have recently hosted a guest and he actually does gear manufacturing. While gear may sound like a very simple manufacturing process, it's a very complex device to be able to manufacture. And I was having the same conversation with him and he was like, I get all these designs and majority of the time I will not be able to use them because these guys, the engineers, they have never built a gear in their life and they don't know what is really involved in making a gear. So sometimes it's just hard for me to be able to negotiate. So I can so relate with the story because the engineers are going to design or define the way they perceive the process to be. And sometimes they are going to be super authoritative as well with the manufacturers that, this is how I want. And then my manufacturer or the supplier is going to say, this is not going to work. And if I design it this way, you are going to be wasting your money. So now my question to you is going to be related to this story is, so let's say if you don't have the 2D drawing, in case of your 3D models, the problem was going to be solved. Is that because you are communicating it better? Because my assumption would be that irrespective of whether you are sending the design or you are sending the 3D model, the gap here is really in understanding the manufacturing process, how that part is actually manufactured, right? Not just in theory, but in the real life, how that is manufactured. And typically this communication gap is going to be because they are not going to have as much visibility into the actual manufacturing process, how these materials are going to be interacting, what are going to be their properties, and if those materials are the right fit for the manufacturing process or not. That's where majority of the gaps are going to be. So in case of 3D models, is this problem going to be slightly better? Is that what you're saying instead of 2D drawings?
So let me make sure I understand the question. You are saying, and I like your example of the gears. Even in a 2D world for gears, it's difficult for a designer and a manufacturer to work together because of the communication of materials or the involute tooth profile or how those gears are hobbed and they're normally ground, right, to get a
Yes.
really good surface finish, things like that. Okay.
Yes.
So I think the short story is, yeah, of course, it's going to improve with the 3D model. And I think
Okay.
here's the reason why. We start like the industry,
Yeah. Yeah. Yeah.
when we, the industry, started to move away from looking at 2D models to seeing how 3D models could help our processes, we discovered things like, I'm not really communicating very well on this drawing
Yeah.
what the involute tooth profile is, for instance, and I don't really know how. And so what 3D models technology, and there's a lot of it, right? There's a lot of technology around 3D data and how we
Yeah.
use it. What that exposed is, it's really a cost of poor quality, which is my drawings are really bad today.
Yeah.
Just
Yeah.
really bad. I just don't really know it. So we can avoid that cost of poor quality by reimagining the way we do business into 3D models, because we have so much, we have a whole another third dimension, right? It's no longer just 2 dimensions. I get 3 dimensions, and I sort of kind of get a 4th dimension, which is all of the metadata, and we call that attributes, all of that metadata information that surrounds that gear. So let's say it's a brass gear. Let's make it a worm drive.
Yeah.
So it's a brass
Yeah.
gear. So we have low friction. And so what is that material and where does it live? Well, it lives inside of an attribute that gets carried along from the native CAD model, like a Creo NX or CATIA or something like that kind of
Yeah.
model. And we stick it into an attribute that persists. And that attribute, for instance, for material, we have normalized in our ASME Y1447 standard. So now I'm layering in the need for standards on top of a PLM and the 3D model to kind of build out your model-based ecosystem. So, but now we've got an attribute that is persistent. It's called material. And
Yeah.
every 3D CAD system in the world can read that attribute. And so it always goes with it. And so what that means is you have a much higher interoperability of this 3D data. Whereas when it's on a drawing, I have to read it with my human brain, and I may have to re-enter that data, brass with this specific heat treat, into another ERP system, into another MES system, into an inventory system. So, but if I author that right up front in my Creo model, for instance, then it persists everywhere and I just read it. I mean, I don't, the computer reads it, right? The computer reads it, it reuses it, we can search by it, etc.
So now let's move to some of the tools that you have in the 3D model space. So now let's say that I am definitely convinced that 3D models are going to help a lot, obviously from the visualization perspective, overall from the cross collaboration perspective. So now let's say if the manufacturers want to replace their balloon processes with the 3D models.
Yeah.
Okay, what are different tools out there in the market? What are their capabilities? What are some of the limitations or strengths that they might have, in which situations they are going to be helpful? Can you name some of the tools and describe their capabilities?
Sure, I definitely can. And let's focus in, if you don't mind, on that first article inspection use case. Yeah. So the first step that happens in a first article inspection is you have to author the 3D data. So we call that 3D data authoring. Those are tools that are almost always a native CAD platform.
Yeah.
Examples, the big 5 there are CATIA, Creo, Inventor, NX, and SolidWorks.
Yeah.
So those are the authoring tools. That's where we have the capability to put on semantic annotations. Semantic means digitally machine readable information, tolerances that are attached to the particular feature in the geometry. And that's the authoring step. Now, the next step is often going to be what I call 3D data derivative publishing.
Okay.
This means I got to translate stuff from, let's say I got to translate from an NX file, and I have a supplier who is SolidWorks. So I want to get that data in the form that my supplier can use, because NX is fairly expensive, SolidWorks is fairly inexpensive. So as the original developer or designer, I want to be able to help out my supplier. So I then publish a derivative from my native source CAD. Examples of that are going to be STEP, which is an ISO standard, global standard, and we kind of call that a neutral file format. An example that a neutral file format that's interoperable that captures metrology or inspection data is a QAF file. And then I can also go from NX directly into SolidWorks, and there's translators that do that. And just a couple of names, Elysium, CapVidia, CAD-IQ. These are all tools, software tools that facilitate that derivative publishing. So then the next thing you're going to do, because we always get this question, yeah, but Jennifer, I don't trust your 3D data. Your 3D data is crap. You know, I'm at a supplier and I get 3D data from 6 different customers and it's all of varying quality. What do I do? And I go, I know, I got your back on this one. So then what the original design body, whoever that is, must then verify and validate that those derivatives are accurately published according to the source model. And then, so there are kind of checkers that check that derivative was published accurately against the source data. And again, there's lots of different software companies that do that verification and validation, but it's a really important step because then they spit out a report, say, yep, and it's automated. It is not, Jennifer, saving my SolidWorks file as a step model and then opening the step model back again in SolidWorks to verify it. Like, that's not verification. That's just me doing a useless manual human step. The verification and validation tools are actually matching the math of the source model to the math of the derivative model, and they're comparing to see if they're out of tolerance and out of sync. Way better verification and validation than Jennifer opening up her step model in the same tool that she just published it from, if that makes sense.
It does. And thank you so much for specifying all of those steps. I mean, those are super helpful in visualizing the entire process and the tools that are going to be relevant for each of those process steps. So now let's talk about, when we talk about any technology, right? A technology could be fit for a specific situation. It could also be overkill. And in most cases, when I look at the technology, if it is not used appropriately in the right situation, then it typically is overkill. Okay. And sometimes engineers, especially, and again, this is not really a jab on engineers as such, but engineers,
I don't mind.
they actually want to go after every other shiny object, right?
It's true.
So let's say if we look at the 3D models, right? I mean, every technology has its place. That's what I believe in, right? Every technology has its own strengths and weaknesses. So if we analyze these strengths and weaknesses and use in the right context, then we get the real value out of it. So let's say if we analyze different verticals, obviously, if we have very complex manufacturing assemblies, then 3D models are going to be extremely helpful, just because it's going to be much harder to visualize, to track. I get that. But from your experience, which are the micro verticals that you have seen where 3D models are absolutely required, where you have seen, and I don't know if you're going to have any specific KPIs that you might be able to tell that, no, I mean, see, this is not working out for your organization. You definitely have to have 3D models. So tell us about different micro verticals. And if you have any specific symptoms that you have seen, based on which you should decide that you definitely must use 3D models.
Yeah. And I was telling my husband last night, I'm like, so we talked to another company and he said, what do they build? I'm like, I don't care. They make stuff, right? I mean, it's we can do whatever we need to do in any industry, anytime. But we have, that's a generic high level approach, right? When we get into it, it's all about devil is in the details. Yes. So working with aircraft parts versus working with commercial electronics, two very different volumes of production. And that means your emphasis for the capabilities that you're going to grow with 3D data or 3D models is going to be different because of that business value you just discussed. Because no executive in the world is going to give you initiative money to go do something that is fun for you, right?
I wish I had that executive.
I do too. But they're gonna go, fun for you, but is it also business value? So how do we strike that balance? Because there is so much opportunity with 3D data. Because again, I added 2 other dimensions, right? It went from 2D to 4 dimensions. And yes, I realize we don't really know what 4D means, but so we've just kind of blew open Pandora's box on the opportunities. And then it gets really hard to figure out what to go after first. We're just like, oh my God, somebody threw up a giant, they just threw up $1 million and a bunch of $1 bills. Where am I going? What am I doing? So that's when I sit down with a customer, that's one of the first things we talk about is business value. And I have a list of about 15 to 20 capabilities that 3D data can help you with, and a whole list of KPIs, as you mentioned. And it's really all about sitting down and figuring out what makes sense for your business. And so there's always a big discovery process and education to start out with. And then we can dive deep into what are your unique manufacturing processes that we could really improve with 3D data. Do you need in-process inspection live in your machine tools because you're building gigantic amounts of volume of parts, hundreds of, you're building thousands and thousands of parts per day? Or is it really all about getting business value out of first article inspection because you are building new products all the time, but it's a low volume, but you have regulatory compliance like in the aircraft industry? So those are 2 different strategic approaches that then result in different tactical plans for how to go about implementing model-based data at your business.
Okay, amazing. That's it for today, Jennifer. Do you have any last-minute closing thoughts?
Yeah, for executives, I think this seems like a very big risk to their production schedules. And if done wrong, it can really disrupt and completely blow up their production schedules. But what we know with the analysis work that we've done is that there are a lot of manual handoffs and undocumented processes that occur during manufacturing processes today that are really actually adding to your time to market rather than reducing it. And when we go into an MPD implementation, we turn that tribal knowledge into digital data, and then we can automate it. And that's how we can get rigorous documentation processes in place so that you can then take care of or leverage the return on investment, and you can go towards machine learning and AI solutions.
Okay, and my personal takeaway from this conversation is going to be the siloed nature of your organization. The cultural factors, the political factors are probably always going to be there. They are going to be much harder to beat. So one thing you could do to enable your team is probably provide some sort of visualization or transparency, maybe using 3D models that will benefit your organization, that will reduce the stress caused by all of these, political or siloed factors. On that note, Jennifer, I would like to thank you for your time. This has been a powerful conversation.
Thank you, Sam. Appreciate it.
I cannot thank our guests enough for coming on the show, for sharing their knowledge and journey. I always pick up learnings from our guests, and hopefully you learned something new today. If you want to learn more about Jennifer, head over to action-engineering.com. It's action-engineering.com. And get in touch if your drawings cost you time and money. Links and more information will also be available in the show notes. If anything in this podcast resonated with you and your business, you might want to check other related episodes, including the interview with Andrew Wood, who discusses why classifying and promoting the reuse of parts is vital to save costs. Also, the interview with Kevin Mako, who discusses how experimental design and additive manufacturing can help mitigate financial risks with innovative projects. Also, don't forget to subscribe and spread the word among folks with similar backgrounds. If you have any questions or comments about the show, please review and rate us on your favorite podcasting platform or DM me on any social channels. I'll try my best to respond personally and make sure you get help. Thank you, and I hope to catch you on the next episode of the WBS Podcast.
Thank you for listening to another episode of the WBS Podcast. Be sure to subscribe on your favorite podcasting platform so you never miss an episode. For more information on growth strategies for SMBs using ERP and digital transformation, check out our community at WBS.rocks. We'll see you next time.